Well, thank you very much. I'm very pleased to be here, and thank you for inviting me. And also, I'd like to hi to all the partners on the online. Ladies and gentlemen, I'd like to give my presentation about metal additive manufacturing technologies, and I'd like to mention about trends, research trends, and economic side of the additive manufacturing, especially metal additive manufacturing. And I also focus on a little bit more about future perspective in additive manufacturing. I read the scope of the project. I like it very much, by the way. And my name is Oğuzhan Yılmaz. I'm a professor in additive manufacturing section in Gazi University. And I have been working on additive manufacturing about 25 years, I think. I have a mechanical engineering background in Gazi University, and I did my PhD and postdoc research in Nottingham University. I met in additive manufacturing in 2002. We were using the additive manufacturing for repairing of blades. So it is also sustainability actually in terms of the manufacturing. And now I'm a professor in Gazi University, and also I'm leading a research group in Gazi University as well. Of course, as a professor, we have some other roles, like I am a chief editor-in-chief at Science Citation Indexed Journal. And I got some roles in TÜBİTAK, which is a research institute in Turkey. And also I'm now a current and active CEO of a metal additive manufacturing company, which is Metalcore. And also we have an association in Turkey. We founded in 2022, which is Turkish Additive Manufacturing Association. I'm a president of that association. We have almost 50 members and lots of, the attendees. We are organizing additive manufacturing conference. We organized the sixth one last week. I think this is one of maybe the biggest and the most attractive conference in the world. And also I've got a bit roles in some universities as well. So everybody knows about additive manufacturing, but I mainly focus on the difference of conventional methods, which is, the subtractive manufacturing. So in additive manufacturing, we add the materials. In subtractive manufacturing, we remove the materials. So what is the difference? The waste. Actually. In subtractive manufacturing, we waste a lot, but in additive manufacturing, we waste a little bit more than the conventional manufacturing. So this is the main difference. And in additive manufacturing, of course, we produce the parts or we manufacture parts from CAD data. I mean, we actually omit lots of steps in manufacturing, like tooling, like, the other steps like assembling, etc., etc. We send the digital data to the additive manufacturing equipments or machines, then we build the part as it is. This is very good. Right now, additive manufacturing have actually, as a standard, 7 main technologies. I mean, these are the technologies. I'm not going to, explain all of them. But right now, as I said, maybe in the near future, there's going to be more. But right now, we have 7 main technologies in additive manufacturing. And then these additive manufacturing, of course, use the material, raw materials, polymers, metals, composites, ceramics, etc. If you focus on the metal additive manufacturing, we actually use, the 2 states of materials. One is melted materials. We use 2 types of heat source. One of them is arc, the other one is a beam. And that beam could be laser or electron beam. If it is arc, of course, we may use some, the welding arc or plasma arc. So when we do that, basically, we melt the material and we build the part layer by layer. And afterwards, the material solidify and we produce the layer and then we build the part as it is. So this is the one way of, the building the part in metal additive manufacturing. It could be on the powder bed, or it could be powder pad, or it could be wire feeding, etc. This is how we actually manipulate the material. But at the end of the day, we use the metal in the form of powder, in the form of wire at the moment. There is also another, the metal additive manufacturing methods. This is solid state additive manufacturing. We use friction stir welding. we actually, do it, not melting the material, steering the material, and do the layers layer by layer the part. The other one is, which I like it very much also, ultrasonic additive manufacturing. We ultrasonically actually welded each sheet of material and we produce the part as it is. And then this is also a growing solid state additive manufacturing. And well, in my presentation, I try to, all of you to take a look at, a broader view, how additive manufacturing growing. As I said, that in additive manufacturing, there are lots of technologies, but if you take a look at the additive manufacturing maturity index table, or that kind of graphic representation, we see that which methods are going to be right now used widespread in the industry or growing on prototype style. At the moment, powder bed systems, laser-based powder bed system is having, the highest industrialization index as well as maturity, technology maturity index. And then electron powder bed systems also in the same, the lots, but is a bit less than their powder bed system. Right now, actually, that's why powder bed system is selling a lot, sold a lot. So. But of course, we cannot say that the metal additive manufacturing processes are having, the same amount of advantages. When we compare them together, there are some, comparison, the tools that, for example, in terms of complexity, yes, the powder bed, the additive manufacturing systems having more flexibilities to give out truss, the structures, porosities, and very complicated shapes. But in terms of cost savings, actually, it's not that kind of, they have advantages. For example, like WAM, which is wire arc additive manufacturing, in part size has, the better advantages, platform flexibility, post-processing requirement, etc. So we may not say that the one, the method is all the time is the best. So it depends on what kind of, the part that you are going to build. So you have to select the proper, the additive manufacturing method. So you have to be conscious about it. So when we take a look at the market, actually, we see that, last 10 years or 15 years, the market always growing. In the pandemic years, actually, a bit growing is a bit down, but for example, if we take a look at the 2028, so it's growing a lot. And if you take a look at also metal additive manufacturing market is also growing a lot. But if you take a look at the metal additive manufacturing processes like powder bed, directed energy deposition, binder jet, you can see the amount. Yes, the powder bed systems has a big market size. And when you compare the DAD side, because of the, the maturity index. So it is now easy to use and the software is now the fully, the developed. So you can use these systems in the commercial side. That's why it's sold a lot. But especially the directed energy deposition system also being sold a lot because it gives the high flexibility to build large scale parts as well. If you take a look at the countries and in terms of installed industrial systems, these are the, the 15 countries in the, the order. As you can see, Turkey at the moment is the 10th country which is installing the AM systems. Of course, the US is the first because they invest a lot, actually. China, of course, is coming. And Germany is leading this technology, of course. And Japan, Italy, South Korea, UK, of course. UK, they use these additive manufacturing for education purposes. A lot of PhD and, MSc research. So that's why actually they, admitting, the lots of students. So that's why they invest a lot. But Turkey is not very bad situation, it's good situation in terms of installation. But when you take a look at the research, it's not that, similar. I'm coming back to here, but I like to a little bit actually focus on additive manufacturing materials, because in additive manufacturing materials, that kind of installation mostly for polymer, the base additive manufacturing system is installed. And everybody, I mean, most of us have our own FDM system in the house, so we are using actually a lot. So we have the same system, as you can see. So the polymer is the mostly used material in additive manufacturing. Metal is the next, and the other materials like composites, ceramics, wax, sand also is coming. But mostly right now, polymer and the metals is mostly used materials. Among the metals, actually, which the alloys are going to be are used in the additive manufacturing, iron base has the most percentage, nickel base, aluminum base, titanium base is coming the next. So that's why actually at the moment the industry is more focused on the iron based metals like stainless steels or the other type of alloys. Yes, the titanium alloys and nickel based alloys, they are most used by aerospace industries, but the commercial sides, cobalt chromes, nickel based alloys in the dentistry, they are very much used. And this is the pricing of AM metal powders. As you can see, the niobium is the most expensive one. Titanium also expensive one, both the wire and the powder. And high entropy alloys also, the expensive, and basically the cobalt chromes, aluminiums less expensive when we compare to the other metals. On the research side, yes, I mean Turkey is the 10th, but I'm so sorry about that. We haven't, the position in the 20, the first 20 countries. So US has the most potential, most, the influential effect on the research. China, England, Germany, Australia, Italy, Singapore. So I know that there are lots of big centers, research facilities, universities have good establishments on the research center and additive manufacturing. And India as well. I mean, India is a growing actually market, as well as they are very powerful in the research as well. When we take a look at the AM research article trends, we see that basically, first of all, I must say that the research publications having not very, the long history. It started in 2010. I mean, mostly, as you can see here. I mean, in 2010 and now on, it's growing a lot, the research. And when we take a look at the research topics, as you can see, mostly designed for additive manufacturing is coming the large scale, because at the moment, the industry and the people, they like to know about how can they use the AM in industry. That's why actually they try to find out that which design would be benefit, so possible to be built by additive manufacturing. Of course, macrostructural and mechanical behavior analysis is the next. But when we take a look at these, the REPAM, the key keywords like digital twins, artificial intelligence, sustainability, and data management, yes, they are on the list. But especially the modeling and simulation having the most to be research in the academic the projects. And these are the shares of AM publications, also the GDP on the research output as well. Again, US, China, Germany, UK, India, Italy, as you can see, these are the countries are sharing these AM publications. And by the need of ChatGPT and artificial intelligence, I got some results. And last 5 years, I searched that these topics like recycling, sustainability, IoT, life cycle, AI, and metal powder reuse. What are the distribution of these academic publications, articles? In the percentage, as you can see, mostly sustainability being searched and worked. And these are recycling, AI, and these are the percentages, the pie charts. And when we look at the the country base, for example, the China shares is 30%, their actual strength areas is sustainability, AI in AM, United States, especially AI, smart manufacturing, digital twins, Germany, about the life cycle, sustainability industrial system, UK, sustainability, India, mainly recycling, sustainability, Italy, life cycle assessments, etc. So these are the main, the strength areas of the countries. And if you take a look at on the company side, the companies, the commercial companies, I mean, they have some products like sustainability and life cycle, for example, Materialize, Siemens, Autodesk, and G Additive has, some solutions and commercial products. And on the recycling, Sabic, HP, and EOS has some products as well. And Renshaw also some products on the the commercial products as well. In artificial intelligence, the Velo 3D, Markforged, 3D systems, and some other, the companies have some products on these, the keywords. And when we take a look at the, the continent side, or the like EU, APAC, and USA, for example, USA, the core strength, especially on the AI, digital twin, and IoT. And EU, sustainability, life cycle, and circular AM, because, like your project, the EU pushed the companies to, especially on the regulations on the sustainability and green technology, and also manufacturing. And Asian Pacific, the countries, they focus on scale, materials, and powder use as well. And we have also a table, as you can see, on which subtopic and which, the region has dominantly, the work on the research side as well as on the commercial side. And these are some of the metals, as you can see, which are going to be, the work on these research focus area, like titanium, aluminum alloys, stainless steel, nickel-based, tool steels, copper alloys, magnesium alloys, and high entropy alloys as well. At the moment, I mean, the most of the research are focusing on mostly used metals like titanium, nickel, aluminum, stainless steel, etc. Yes, I mean, the last, few years, like Professor Sachin's work on high entropy alloys are growing a lot because there are very, very good potentials over there. And also copper alloys and magnesium alloys are also be in the circle. So therefore, mostly research are focusing on these materials as well. These are some of the, the summaries. That's how these materials being actually be economically, why they are being searched or researched actually in the academic, the projects, like titanium, aluminum alloys in terms of sustainability. And so, for example, sustainability perspective, like titanium is very, the popular metal or alloy in the aerospace. So because the bio-to-layer ratio is very critical in aerospace, so that's why actually we have to be, use these titanium alloy as efficient as possible. So these are other materials, the summarizing that economic perspective and recycling sustainability as well. So as a summary, basically, the aluminum is the cheapest one. So the cost level is medium, price stability is high. Steel also another them. Titanium economic value is high. Cost level is also high. And the price stability is medium, may change. Nickel alloys, cost level is very high. Price stability low, it may change. Also economic value, actually economically is also high as well. So as a summary, we may say that life cycle, I think in economic perspective is the first rung in the, the one of these objectives. Life cycle is very critical. And then the AI use in AM is also getting the next one. Sustainability, the third one. Material efficiency is the fourth one. And the IoT and digital AM is the fifth one, based upon the research trends in the last 5 years. So as a concluding, actually, life cycle driven evaluation stands as the ultimate gatekeeper, determining whether additive manufacturing delivers at a real economic and environmental value at scale. AI-enabled process control is essential to unlock productivity, ensure quality, and make advanced materials economically viable. Sustainability is a non-negotiable driver, increasingly dictated by regulation like in EU, and energy costs and global market expectations. Material efficiency remains as a core lever for competitiveness, directly influencing cost structure and resource utilization. IoT and digital integration are critical enablers that support industrialization but true competitive advantage lies in combining all these dimensions into a unified manufacturing systems. So actually, in my perspective, what will be the future trends in additive manufacturing? This is my perspective. I mean, as I said, I have been working on additive manufacturing for about 20 years. So I think micro and nanoscale AM is having lots of potentials. Most of the United States companies or the universities are focusing on these areas, and not EU and Turkey. So there are very big potentials over there. And also smart structures, especially by using ultrasonic additive manufacturing, you actually build the part layer by layer by sheet metals. So you can actually install some, the wires, sensors, and some kind of other equipments inside of the parts. So the part can sense, okay? So the parts can give some data. So that's why we call them smart structures, smart parts. Of course, complicated and detailed designs are going to be very, very critical. So that's why, as you can see, very complicated and very, the detailed structures and parts are going to be designed because additive manufacturing can do that or can manufacture them. Of course, 4D printing and bioprinting is very critical. So 4D printing means that after 3D printing the parts by stimulating by heat or light, the fourth dimension is coming. So that means actually, we have the part as an original shape by giving some heat or light, so it changes shape. So we call it as 4D printing. So there are some actually good applications on that. Also, the bioprinting also very critical as well. Of course, the additive manufacturing has lots of potential in electronics, drugs in pharmacy, and medical as well. So I think it's a good business area and research area in terms of additive manufacturing. So aerospace still, the leading this technology. So as you can see, these are the parts being, built by Turkish company, which is Turkish engine industry. So as you can see, they are very, the complicated parts, but also, for example, on the right bottom part is normally being built about 50 parts. So it is built as it is actually single parts. So in terms of building the 50 parts individually and assembly it, so you can build it as it is on unique part. It's a consolidated part. Of course, in the nozzles and some aerospace and defense purposes, like the NASA use these, actually SpaceX use these nozzles as well. As you can see, they are using these kind of nozzles. Actually, they build it in a single, the machine, and as complicated as possible. Also, large-scale parts are being built by WAM, which is wire additive manufacturing. So big size, like 5 meters, 3 meters, they are built, the layer by layer depositing, so they can be built as a single part. So they even, they send it to the space. So just a list, the multi-laser system, magnetic shape memory alloys, cold spraying, high entropy alloys, the instant control, machine learning, lean design approach, topology optimization, phase transformation. These are some other, the research areas as well as commercial areas, I think. These are some research topics in metal area. And in Turkey, what we are doing, actually, we have an association. Also, we are organizing international conferences. We did the 161 in last week, AMC 2026. Hopefully, we will see you in next year in Antalya, most probably. And this is as I said, very powerful conference. We invite lots of keynote speakers from all over the world, very powerful persons, academics, and from the industry. Do you have a time? Very, few, the short video. I think one of the best, the platform for the companies and the academics to be to gather together actually and to talk about additive manufacturing. So as I said, hopefully next year we will be there. And as Additive Manufacturing Association, we do a lot of activities actually. So we organize summits. We actually we have the special issues and journals, and also we involve the projects as well. And thank you very much for listening to me, and hopefully you will get some the idea what we are doing and about additive manufacturing. Thanks a lot.